We are coming rapidly toward the end of chapter 2, and of course that will mean that as we wrap up chapter 2, next time, our next session together, we'll wrap up chapter 2. That means that we will be having a test on chapter 2. And again, I mentioned, hopefully you agree, chapter 2 is probably one of the easiest chapters in the book, much more simple than chapter 1. Okay, so anyway, today we're going on to section 6. In chapter 2, we're going to be talking about the algebra of functions and also composition of functions. And there's my good old friend back again. All right, so let's talk a little bit about the algebra of functions. The algebra of functions just means that you can add, subtract, multiply, and divide functions like you can numbers. You can add two functions by simply adding them together. You can subtract two functions, and I forgot the parenthesis in there, by simply subtracting them. You can multiply two functions by multiplying. You can divide them simply by dividing. This is not brain surgery, folks. It's actually pretty easy. F of x is 3x squared. G of x is 2x squared. Can you find f plus g of x? Then we would know that f plus g of x, you simply add the two together, and it would be 5x squared, right? F minus g of x, you simply subtract the two. F minus g of x would be 3x squared minus 2x squared, or just simply 1x squared. If you multiply the two together, f times g of x would be 3x squared times 2x squared is 6x to the 4th, and divided by f divided by g of x would be 3x squared divided by 2x squared. Now, this one you have to be a little careful. I understand I can cancel out the x's, but the way this is stated, you cannot have x equal to 0, okay? So this is your function, and go ahead, you can cancel out the x squareds and get 3/2, but you've got to stipulate that x cannot equal 0, okay? How about this one? Let f of x equal the square root of x minus 2, g of x equals 3x, find f minus g of x and its domain. Okay, so f minus g of x would be f of x minus g of x. Simply that. Now, what's its domain? X can be anything here, but you can't take square roots of negatives. All right? So x could be 2. 2 minus 2 is 0. If x gets bigger than 2, like 3, 4, 5, doesn't this always stay positive? And you can take square roots of that. But if x is even just minutely smaller than 2, like 1.9, you've got a negative value and you're in trouble. Okay, so the domain, even though it's everything for this one, the domain here limits you that the domain would have to be reals bigger than or equal to 2. Yes? Okay. Now let's talk about g divided by f. G divided by f would be g is 3x over x minus 2. And what about the domain of that one? Here we've got a problem once again. Not only can you not take square roots of negatives, and numbers smaller than 2 gives us a problem there, but in this case, x cannot equal 2 either, because you'd have division by 0. 2 minus 2, 0, square root 0, okay? So the domain here would be reals strictly bigger than 2. It cannot even equal 2, okay? Everybody all right on that? The algebra of functions, you can add, subtract, multiply, divide. Really, really, really easy, okay? All right, Most of what we're going to talk about today is composition. It's really not a difficult subject. This is a huge calculus subject. You will do an awful lot of composition of functions in calculus. So it is important that you understand what's going on here. So let's talk about it. That helps, a little light on the subject. Here's the definition of composition. Let f and g be functions, then the composition of f and g is denoted by a little circle. This is not a dot. A dot means multiplication. This is a tiny circle. F circle g of x is equal to f of g of x. And remember, you always do what's inside of parentheses first. So you would have to do the g of x first, get your answer, and then put it in for the x in the f of x function. I'll say it again. F circle g of x is f of g of x. You must do the second one first, get that result, and put it in as the x value for the f function. So let's try some problems. F of x is x squared, g of x is x minus 3. F circle g of 7 is f of g of 7. Okay? 7. All right? So you must do g of 7. G of 7, is it not 4? So I have now f of 4. And f of 4, is it not 16? Yeah? Okay? How about g circle f of 7? I wonder if composition is commutative. Can we do it forward and backwards? Can everybody see what I'm doing here? I better write a little bit bigger. Okay, so g circle f of 7 is g of f of 7. So I must do f of 7 first. F of 7 is going to give me 49. So it's g of 49. Okay? Because I did 7 squared, 49. Now I put 49 in here, and 49 in there gives me 46. And no, they are different. Composition is not necessarily commutative. Sometimes it is. Sometimes it's commutative, but it's not necessarily commutative. Okay. How about f circle g of dollar sign? F circle g of dollar sign is f of g of dollar sign, right? So I must put dollar sign into the g function first. And don't I get dollar sign minus 3, correct? And then I take that result and put it into the f function. So my answer is dollar sign minus 3 squared. You can square it out if you like. Write it down twice. Don't take the 2 in. Dollar sign times dollar sign is dollar sign squared. Outers and inners are both negative $3 sign. Negative $3 sign is negative $6 sign. And negative 3 times negative 3 is plus 9. So either answer is fine. Okay? Length of a side of a square is growing at a rate of 5 inches per minute. So the length depends upon the minutes. 5 times each minute. After 1 minute, it's 5 inches long. After 2 minutes, it's 10 inches long. 3, it's 15, and so on. The area of the square depends upon what the length is, and isn't area length times width. And because it's a square, they're both the same. So the area of the square is L squared. Okay? Is the area of the square A circle L or L circle A? Now remember, you always do the second one first on composition. You do the G first. Okay, so which should you do first here? The L or the A? Well, don't you have to find the length of the side first before you can find its area? So it should be A circle L. You do the length first to get the length after so many minutes, and then you take it times itself to get the area. These are my favorite problems in composition. These are a lot of fun. Now, when you have two pictures. Here I have a green function. It's a little fuzzy. I'm hoping you can see that all. Starts here, stops there. Here's a red function, starts here, stops up there. Okay? So we want to answer some questions about composition of functions and addition and subtraction. Now I'm going to save the addition and subtraction until the very end. Okay? Let's do the composition first. If you have f circle g of 3, don't you have to do the second one first? You do g of 3 first. Now g is the bluish greenish one. So where does 3 go? On the bluish greenish one, it goes up to 1, 2, 3, 4, and not quite 5. I'm thinking it's like 4 3/4 or something like that. That's what g of 3 is. Then you have to take that 4 3/4 and you got to stick it into the f function. So 4, 1, 2, 3, 4, and here's about 4 3/4. 4 3/4 is going to go up to here, which is 1, 2, 3, maybe 3 3/4. So the answer to this one is 3 3/4. Let's do that one more time. You do 3 first into the g function, 1, 2, 3, 4, 4 3/4. Then you take the 4 3/4 and put it into f. 1, 2, 3, 4 3/4 goes up to the red one, 1, 2, 3, and about 3 3/4. So 3.75 for this one. Let's turn it around. How about g circle f of 3? In g circle f of 3, you do the f one first. So f of 3 in the red one, f of 3 stays at 0. Correct? So f of 3 is 0. Then you take that 0 and put it into the g function or the green function, and 0 is going to go up, looks like it's pretty close to 3. So the answer to this one is 3. Okay? Go down here. How about this one? F circle f of 4. We're going to do the f function twice and ignore the green one. How about f of 4? Where does 4 go? 4 goes to 2. Then you take that 2 and you put it into the f function again, and 2 goes to -2. Ha! Aren't they fun? You have a few of those in your homework. Those are a lot of fun. Now, I said I wanted to reserve these two until the end because I'm going to be messing with that picture a little bit. I want to add f and g. You can only add f and g where they're both defined. So I can't add anything to the g over here. I don't have any red. The red one starts here, f starts here. So we're going to start at 0. And the green one stops at 4. So I'm going to have to stop at 4. I can only go from 0 to 4. That's the domain for this function right here, from 0 to 4. And I'm going to add the values. Okay, so here we go, starting at 0. If you start here, the functional value is 0. Functional value here is 3. 0 plus 3 is 3. Okay? We're going to go from 0 to 4. At 1, the functional value is -1. The functional value here is +4. -1 plus +4 is 3. Okay? Then I did 1, now I'm going to do 2. 2 on the red goes to -2. 2 here goes to 5. -2 plus 5 is 3 again. Okay, this is kind of weird. And finally at 4, 4 goes to 2. And 4 on the green goes to 3. 2 plus 3 is 5. And I think 0, 1, 2. Yeah, what am I doing? I missed 3. Sorry, let's do 3. 3 goes to 0 here, goes to 5 here on the green. So 0 here, 5 on the green. 0 plus 5 is 5. And now let's do 4. 4 goes to 2 here and 3 here. So 2 plus 3 makes 5. All right, let's go back and double check this. 0 and 3 add is 3. -1 and 4 add is 3. -2, 5 add is 3. 0 and 5 add is 5. 2 and 3 add is 5. So you connect the dots. Comes over here like this, comes like this, comes like that. okay? And there, the blue represents f plus g of x. Now, let's do f minus g of x. Okay, I'm going to subtract the f minus the g. So we've got to be careful how we do this. And once again, we're only going from 0 to 4. And we're always going to take red minus green because it says do f minus g. So I want 0 minus 3 is negative 3. I want negative 1 minus 4. Negative 1 minus 4 is negative 5, which is down here too. Okay? Negative 2 minus 5 is negative 7, which is way, way down here. Okay? Then at 3 is 0 minus, it looks like pretty close to 5. So 0 minus 5, we're back up to negative 5, which is right here. And finally, 2 on the red minus 3 is negative 1. Connect the dots, and I go down like this and up like that. And that function represents f minus g of x. Let me get rid of that. Okay? Okay. How about no pictures? No pictures. Here's what f is, here's what g is, here's what h is. I want to do f circle g circle h. So the first one you do is the very last one, h. So I must put 3 here and get 9. Then I put 9 where? Into the next one, going backwards. You put 9 here, and don't we get 7? And then don't I put 7 here, and the answer to the first one should be the square root of 7. You can either let your answer the square root of 7, or you can take the square root, and you can get 2.65. Okay? Next one. F circle G circle G. So I don't do anything with H. 8. I must first put it in the G function and get 6. I take that result of 6 and put it back in the G function and get 4. Okay? I take that result of 4 and put it in here, get square root of 4, which is 2. Yes? Okay. Down here, I'm going to put 16 and do it in F 3 times. So I do the square root of 16, 4. Take that result, put it back in, square root of 4. 2. Take that result, put it back in. Square root of 2 is the final answer. Or my brain is working, it's 1.414. Now, what about this? F circle G circle H of x. You got to be really careful when you're doing these with x. So I'm going to first put x into the h function, and I get x squared. Correct? So I better write this out. So I want f of g of h of x. Okay? So I first put x into there, and I get x squared. So I want f of g of x squared. Right? That's what h of x is. It's x squared. Then I put x squared here in for that x. And don't I get x squared minus 2? Are you with me? Okay? Then, am I writing big enough? Make sure everybody can see that. Yeah, I think so. Okay, then I've got to put the x squared minus 2 in here. And I get a final answer of the square root of x squared minus 2. Okay? Last question. Find a new function, q of x, so that g circle q of 5 is back to 5, where it started from. Now, let's think about this. We don't know what q is. It's going to do something to 5, so that when we take that result and put it in g, we want to then get back to 5 again. Okay? Think what you have to do to 5 to get something so that when you subtract 2, you get back to 5. In other words, to subtract 2 and get back to 5, don't we have to have 7 from this? Doesn't q of 5 have to go to 7, so 7 will go back to 5. So how can we get 5 to go to 7? Q of x would have to be x plus 2. We need to add 2. Then we can take the 7 and subtract 2, and we're back to 5 again. And this, I just couldn't help myself. I had to do this with you. This we call the inverse function of that. Add 2 and subtract 2. They're opposites. Add 2 and subtract 2. That is where we're headed on the last section in chapter 2, 2.7. We're going to be talking about inverse functions, a really, really cool topic. Hopefully you'll enjoy it. Homework. I've got one extra problem. It's an absolute value graph. You should be able to sketch that right now with what we went over our last time together. Find the increasing, decreasing intervals of max, min, point, find the domain and range, and then some problems in the book.